Hello, and welcome to my presentation on assessing the resiliency of the Sachuest Point Remediated Landfill. My name is Tabor Midgley, and I'm a project engineer with EA Engineering, Science, and Technology out of our Warwick, Rhode Island office. A quick point about the cover photo here. To the left, we have Sachuest Bay and Second Beach. Down the center is Sachuest Point Road, and the elevated topography to the right of the road is the Sachuest Point Remediated Landfill, which we will be discussing. A quick, brief site introduction. The project is located on the Sachuest Point National Wildlife Refuge, which is on the southeast tip of Aquidneck Island in Middletown, Rhode Island. It is 242 acres, sandwiched between the Rhode Island Sound to the southwest and a Sachuest River tidal strait on the northeast. Newport can be seen in the background, with First Beach off in the distance, and Second Beach and Third Beach immediately adjacent to the refuge. Finally, we have the Visitor Center directly in the center of the photograph. This is part of the larger U.S. Fish and Wildlife Service Rhode Island National Wildlife Refuge Complex and supports important wildlife such as New England cottontail, harlequin duck, saltmarsh sparrow, and over 200 other seasonal bird species. Important habitat types it supports is shrubland, cobble beach, and saltmarsh. In summary, this is a popular destination for tourists. It provides unique habitat and is important for various species. Today we will be talking about the Remediated Landfill, which is located here adjacent to Second Beach. So the landfill is approximately 15 acres, located very close to Sachuest Bay. A brief history, it was subject to unregulated dumping as early as 1951, operated as a municipal landfill until 1973, then a transfer station for a couple years. Waste operations finally ceased in 1975. It was subject to CERCLA investigations between 1994 and 1997, when it was classified as a low priority, and EPA recommended no further work done unless recommended by RIDEM, the Rhode Island Department of Environmental Management. Accordingly, a site investigation report was prepared under RIDEM regulations in 1998, and a remedial action work plan followed up in 2003, with the remedial action being completed in 2005. As you can see in this historic aerial, the red circle to the south is the high fill area, or basically the current footprint of the landfill. To the northeast of that is what we call the low fill area, which also had waste. Part of the remedial action was relocating that waste into the high fill area, which was then capped with several soil layers and then a polyethylene liner. Stormwater and gas venting systems were installed, and the low fill area was restored as a tidal salt marsh, as you can see in this aerial. To briefly discuss the contaminants of concern within the landfill, there's widespread distribution of several chemical compounds, including PAHs, pesticides, PCBs, hydrocarbons, and metals. These are at relatively low concentrations, but there are exceedances of regulatory and guidance levels in several media. This is very typical of constituents found in landfills that operated in this time period. Lead is the primary concern as it consistently exceeds RIDEM criteria in more than one media. Under current conditions, the landfill generally poses little risk to human or ecological receptors because it is closed, or so we thought. In 2012, Superstorm Sandy made landfall on October 29th and was rated between the 10 and 25-year recurrence interval event by the time it made landfall in Rhode Island. As you can see in this photo, Sachuest Point Road was completely undermined and made impassable. That is the visitor center off in the background. The landfill itself was covered in debris and beach sand. Post-Sandy, repairs were made which consisted of slope armoring, road reconstruction, and reinforcement of the landfill toe. I have this photo here, which is present-day Sachuest Point Road, looking in the opposite direction, but you can see the slope armoring to the left. There's also toe armoring at the toe of the landfill to the right, which you can't really make out, but it's there. So, as a result of Superstorm Sandy and the encouragement of the town of Middletown and the U.S. Fish and Wildlife Service, EA was selected to evaluate the landfill cap as to its vulnerability now and into the future to damage associated with storm surge and catastrophic weather events. Data and models we've utilized included the 2015 North Atlantic Coast Comprehensive Study, the Wave Height Analysis for Flood Insurance Studies, WAFIS, and Run-Up. So some of the data that we relied on included USGS topobathymetric elevation model, which was conducted, or data was recorded for it after Superstorm Sandy. We also, as I said, use the comprehensive study results for the 100-year average recurrence interval storm event, which provided the still water elevation and significant wave heights for whatever storm event we wanted. For this evaluation, we used the 100-year event. And finally, for sea level rise, we used, consistent with state guidance, we used NOAA's 2017 high sea level rise curve and evaluated 4 different time periods, present, 25 years from now, 50 years, and 75 years. As you can see in the photo, this is the comprehensive study locations within Sachuest Bay. There's 10 locations within the bay itself. We really focused on the 3 there, which basically form a perfect cross-section right into the landfill. Here we have some of the wave height data. So with the comprehensive study, a significant wave height of 17.1 feet and a wave period of 11.4 seconds. Then we edited the data for WAFIS and Run-Up to calculate the waves, overland waves, and wave run-up on land. So for sea level rise projections, I just wanted to give this table to show what magnitudes of these that we ended up using. As you can see, we have in the 4th column, we have mean sea level. So 2018 is 0.6 feet, 2.2 in 25 years, 4.5 in 50 years, and so on. And we also have the 100-year still water elevation, which is significantly higher. So I just wanted to note some of the methods and limitations of this study. Basically, the 100-year storm characteristics predicted by the comprehensive study were applied as is to each sea level rise projection. In other words, if we had a significant wave height from the comprehensive study, that significant wave height was the same no matter which sea level rise projection we were evaluating. However, in actuality, as a result of climate change, those characteristics may change along with sea level. For WAFIS and Run-Up models, they were developed only using a single coastal transect, which you can see in the figure on this slide. However, the coastal zone in this area is relatively uniform, so it should be pretty representative. And finally, we only evaluated waves from one direction, the southwest. However, this is perpendicular to the shoreline and landfill, which therefore energy transfer should be the strongest in this direction, and also the southwesterly direction has the largest fetch and is generally the worst case scenario. You can see here also on the figure the 2018 mean sea level, the kind of the cross-section, the Bathian topographic data. You can see the Sachuest Point Road and the armoring at the landfill and the landfill itself. So, results. This first chart shows the 2018 results, so present sea level rise. At the bottom of the chart, we have mean sea level at 0.6 feet. We have Sachuest Point Road, the yellow, the landfill riprap at the toe of the landfill, and then the landfill the rest of the up to the peak. The 2018 still water elevation is at 13.4 feet. So even without waves during a 100-year storm event, the road and the landfill armoring are submerged. When you start including wave setup and wave envelope, we are experiencing energy transfer onto the grass cover of the landfill, directly onto the cover, the unprotected cover. And this is without sea level rise. I'm not going to show the 25 and 50-year results because they are just steps in between the 75-year results, which I'm showing here. Basically, in 2093, mean sea level is basically at the road or higher. The storm elevation, still water elevation for a 100-year storm is nearly towards the top of the landfill and waves completely overtopping it. So we also evaluated existing cap vulnerability. As we saw during Superstorm Sandy, anecdotal evidence indicates that storms below a 25-year event can impact the toe of the landfill slope, as we saw by the debris being distributed across the landfill. EA evaluated the vulnerability using Army Corps of Engineers methods, and we found an overtopping discharge right at the top of the armoring of 175 cubic feet per second per linear foot. When converted to a velocity, this greatly exceeds the allowable flow rate of grass cover and indicates that significant erosion would occur. It was, however, determined that the stone armoring was sized sufficiently to handle velocities, just not placed to the elevations required. So, conclusions. The Sachuest Point Remediated Landfill is susceptible to coastal storms. Under present-day sea level, the landfill cap will be impacted by a 100-year average recurrence interval storm event, potentially eroding soil, damaging the liner, and releasing contaminated material into the environment. These impacts will only be exacerbated as sea level rise continues. In fact, with present-day sea level, the cap is already vulnerable to storms less than the 100-year ARI. As sea level progresses, the ARI that threatens the unprotected portion of the cap will decrease, meaning as sea level rise progresses, smaller and smaller storms will pose greater and greater threats to the landfill cap. So, solutions and path forward. We are working with the U.S. Fish and Wildlife Service now to perform an engineering evaluation and cost analysis on several alternatives. A quick summary of our remedial action objectives include taking preemptive action to protect human health and natural resources, preventing mobilization of landfill debris and contaminated soils, preventing mobilization of contaminants into groundwater, minimizing the resources needed for repetitive maintenance, and maintaining and improving ecological habitats at and near the landfill. Our preliminary alternatives include additional landfill armoring, nature-based surge protection such as a beach dune system, and partial or complete removal of the landfill with off-site disposal. So, in final word, this project has demonstrated that this remediated and closed landfill is susceptible to large storm events and sea level rise. It is very important to note that this is just one example. There are many active and closed hazardous and contaminated sites across the country in the same situation, and something that we need to evaluate. Thank you for your time. Please feel free to contact me if you have any questions.